Hey, this is Randy. Today we're going to talk all about geometric series. First of all, we'll talk about what is a geometric series, and then we'll go into detail about how to find the sum of a certain number of terms in a series, and then we'll talk about how to find the first term in a series if we don't already know it. Let's go. So before we even talk about the definition of a geometric series, let's talk about the significance of each of the variables in this formula. So each of these variables will make a lot more sense after we do some actual examples, but really quick, let's just talk about the significance of each one. So S sub n refers to the sum of all the numbers in a given series. So if we add all of them up, that is S sub n. Now A, just like A is the first letter in the alphabet, A is the first term in a given series. It's the first number. Now we have R twice in this formula, so there's an R in the numerator and in the denominator, and that R represents the common ratio. We'll talk about what that means here in just a few moments. And lastly, N is the number of terms or the number of numbers in a given series. Now let's read this definition together and then we'll get into some examples. A geometric series is a progression of non-zero numbers where each number after the first is determined by multiplying the previous one by a fixed non-zero number called the common ratio. If that feels kind of strange and difficult to follow, no worries, it'll make a lot more sense after we do some examples. So first example, given the following series, what is the sum of the first 5 terms? And here we have that same formula that we just talked about. So we need to find the sum of the first 5 terms. So we're going to try to find S sub n. So I wonder, can we find the value already of every variable on the right side? The answer is yes. So the two variables that are easiest to identify immediately would be A and n. We know that A is the first term and 2 is that first term. So A is 2 and the number of terms they tell us is 5. So 5 is n. Now, how do we find r? That's the hard part. And it's really not that hard, but the question is to find r. What did we do to one term in order to get to the next? More specifically, what do we multiply 2 by in order to get 8? In other words, 2 times what is 8? 2 times 4, right? And now 8 times what is 32? Again, times 4. So this number 4 that we need to multiply each term by in order to get the next term is what we call the common ratio. So now let's rewrite this right side of the formula with all those variables replaced by actual numbers. So now we have S sub 5 is equal to, instead of A we have 2, instead of R we have 4 and 4, and instead of n we have 5. So 2 times 1 minus 4 to the power of 5 all over 1 minus 4. Now what? Well, let's just simplify this entire right side of the equation, and that will give us S sub 5, or the sum of the first 5 terms. Well, in case you did not already know it, you can write 4 to the power of 5 in your calculator by writing, first of all, 4, and then the button that has the little like arrow pointing up means to the power of, and then 5. And that's the same as saying 4 to the power of 5, which is 1024. So now let's simplify 1 minus 1024 is negative 1023. And now let's simplify the top and the bottom. So 2 times negative 1023 is going to be negative 2046, and 1 minus 4 is obviously negative 3. And negative 2046 divided by negative 3 is what? 682. So the sum of those first 5 terms in the series is 682. That's the answer. Now, if this series had like way more than 5 terms, it'd be difficult to check it manually, but because we have only 5, we could, if we want, say 32 times 4 is 128, and 128 times 4 is 512, and when you add up these 5 terms, you do in fact get 682. So we just verified that the sum is in fact 682 by checking it manually. However, if you know how to use the formula, then that's even better because you can solve for the sum of any arbitrary number of terms, even if that number is like really big. Okay, beautiful. Let's do another example. So again, we need to find the sum. It says, given that the first term in a geometric series is 64, that's going to be a, right, first term, and the common ratio is 0.75, that's going to be the r. What is the sum of the first 4 terms in the series? So 4 is going to be n. So first things first, let's set up our equation with each of those variables replaced by a number. So, like I said, our a is 64, our r is 0.75 on the numerator and the denominator, and our n, in this case, is 4, the number of terms. Now, a pretty easy way to do this would be to put this entire numerator in your calculator and then write what you get after you press equals. So in your calculator, you're going to put 64 and then an open parentheses, just like that, and then 1 minus 0.75, and then that same button that we used before to indicate to the power of, and then you're going to type 4, and then close the parentheses, and then what do you get? As usual, I encourage you to always try these problems before we do it together, including this one. So assuming that you have already tried it, I'm going to continue. So that entire numerator simplified is 43.75. These instructions right here are for using a scientific calculator. If you have a different type of calculator, it might be a little bit different, your process. So whatever type of calculator you're using, make sure that you're expressing this exponent of 4 correctly. So let's replace this entire numerator with 43.75. All right, now this is looking a lot more simplified. Let's rewrite the bottom as, instead of 1 minus 0.75, we'll just write 0.25. All right, and lastly, what is 43.75 divided by 0.25? That gives us 175. So we have the answer, but what would this series actually look like if we wrote out each term? Well, 64 is that first term times 0.75 gives us 48. 48 times 0.75 gives us 36. 36 times 0.75 gives us 27. And when we add all of those up together, we do in fact get 175. All right, now our last example is where we need to find the first term, a. Given that the sum of the first 4 terms, okay, so 4 is n, of a geometric series is 120. This time, this 120, they said is the sum, so that corresponds to s sub n. And the common ratio is 0.5, or 1/2. What is the first term? What is a? So first of all, let's set up the equation real quick. All right, there it is with all of our variables replaced with numbers, with the exception of a. You'll notice that the denominator was 1 minus r in the formula. So that is 1 minus 0.5, right? So 1 minus 0.5 is 0.5. So immediately I just wrote 0.5. So let's try to simplify this numerator a little bit, and then we'll try to isolate a. And I actually, real quick, forgot to write 120 in place of s sub n. So let's do that. All right, there it is, 120. So now if you put this entire expression inside the parentheses in your calculator, what do you get? Well, 1 minus 0.5 to the power of 4 will give us 0.9375. Now we have divided by 0.5. So let's multiply both sides by this 0.5 to get rid of that fraction. So the right side times 0.5 gives us just what we had in the numerator, and the left side times 0.5 will give us 60. Last step is to divide both sides by this 0.9375, and then we will have a. So when we divide the right side by 0.9375, we get just a, and on the left, 60 divided by the 0.9375 gives us 64. All right, so now that we've practiced finding the sum of a certain number of terms in a geometric series, and that we've practiced finding the first term in a geometric series, we are finished. See you next time.